Good evening. Hello again, sick, twisted weather freaks. This is another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host, meteorologist DT here from Weather Risk, your commander of chaos, your colonel of confusion, your captain of catastrophe. Let's talk about This Week in Weather for this October 3rd, about 12:30 in the morning. And wanted to get this video out earlier, but workload over the last week has been really heavy, so let's get right to it, see what's going on here. A lot of talk about more potential tropical activity. We'll see that that's probably not going to happen after this week. Looks like the tropics are going to shut down, especially coming off the coast of Africa. That's a pretty certainty. And then the upper air pattern is going to become extremely unfavorable for any sort of threat to the U.S. East Coast or the Gulf Coast, from what I can see for most of October. It does look like we got a couple of cold shots coming in here, getting into the heart of autumn. So let's get right to it. This here is the Weather Risk Rain's Twitter page, and right here is the Facebook page. Now here is a picture from the Asheville flood from 1916. And I wanted to point this out to you so you could see what it looked like here back in 1916. And what's interesting is that you can see the sign here that remembered the 1916 flood from more than 100 years ago. Let's see, 1916, 108 years ago. And obviously this is a picture of it, so it was quite devastating. But the point is, it happened once before. You know, in Asheville in particular, it's caught between two rivers. If you're not familiar with the geography of it, you can take a look at it on Google Maps or what have you. There are two significant rivers that flow through Asheville. So when they flooded the banks, it was pretty bad. But the whole area is like that. This is from a town, I think it's called, this is from Marshall. The picture of the destruction there and the cleanup, it's been pretty bad, as you can see. Now, a lot of the super heavy rains have receded, but not every place. And the reason for that is because of the destruction. This here is this is from September 28th, I guess the day after the hurricane or the evening of the hurricane. You can see the blackout of the infrastructure grid, the damage that was done right in that red area as the hurricane came ashore. Quite impressive. It just ripped up the entire infrastructure, you can see. And it's all dark there. And probably still dark in most of those areas. Look at the rainfall here in the last, for the storm. This is from Greenville, Spartanburg, NWS. And you can see it, that purple color right in here. That's 15, 20 inches of rain. Look at 24.0 inches here, 30 right here in Yancey County. And what's happened is all this moisture that was 4, 5, 6, 8 inches of rain got lifted over the mountains of the southern Appalachians and even into northeastern Georgia. And you had this tremendous rainfall. This is exactly what we said was going to happen. This is not a surprise. This is not unheard of. This happens all the time. When you take tropical moisture and you lift it into the southern Appalachians, and the week, several days before, you have moderate rain of several inches, also causing localized flooding even before the hurricane. And you would end up with a disaster, an absolute disaster. Very, very sad conditions there, very bad. And of course, the loss of life I think it's going to break over 250 from what I can see. Anyway, this is the official rainfall maps, and these numbers are just staggering. Not just over 30 inches. I mean, I don't know how real that is or isn't, but you can see there are a lot of places over 20 inches of rain here. And then you can see the huge numbers of heavy rains all around. Look at Georgia, northeast Georgia, almost 15 inches there. Upstate South Carolina, 13 inches. Pretty impressive. Pine Mountain, 17 inches of rain there. Wow. Rocky Bottom, that's in South Carolina, 21.6 inches. Impressive to say the least. Wow. Tremendous amounts of rain there. So, quite impressive. The winds also, Mount Mitchell, of course, obviously, is got the highest winds here in the Appalachians. Obviously, had much higher winds than this in Florida, the Panhandle, but this is for the southern Appalachians. And you can see the winds are quite extensive. And there were gusts for hurricane force gusts. Mount Mitchell, Sassafras, Anderson, even Greenville, Spartanburg, which is the town, not the mountains, 68 mile an hour wind gusts. Charlotte, 66, downtown Greenville, 64. A very impressive wind gusts here. We said this was going to happen. We predicted there would be hurricane force gusts or winds over 65 miles per hour in the height of the storm when the core of the system came inland and began to interact with the large closed upper low. that was located in Missouri and western Tennessee. That's exactly what happened. So this was exceptional, the upper air pattern, in addition to the rain. And the whole thing was just a series of unlikely events, but predicted. Now, again, you have a lot of people that say, well, yeah, it's going to be bad, but it's not going to be that bad. Or, they think the media over-exaggerates, and sometimes it does. And then you get these really catastrophic events, and people go, what? How did this happen? Well, sometimes when we say it's going to be really, really bad, it's going to be really, really bad. As much as you may not want to question it, sometimes science works. Sometimes it works really, really good. And this forecast from everybody, myself, AccuWeather, all the private meteorologists, the Weather Channel, WSI, they were all handled it extremely well. NWS was on top of this. Hurricane Center was on top of this. This was spectacular forecasting. The models were unbelievably good, and people should have been more aware it was going to be this bad. But there you go. Now you're going to see a lot. You've seen a lot of this in the media here. Inside Climate News here, how the climate change intensified Hurricane Helene and made the floods possible. This is from our friend Sean Sublett, meteorologist who used to be here in Virginia. And again, he mentions that 1895, 1916 floods, but you can see that the water levels, the French Broad River crested at 24.67 feet in Asheville, the highest since records began in 1895, exceeding more than a foot and a half from 1916. South of Asheville, the Swanee River, 26.5 feet, which is 5 feet above the previous record. So, and in 1916, there was also two weather systems that interacted with each other. And here, we had the same thing happen again. So, the point here is, I'm not going to get into whether or not climate change causes hurricanes. It doesn't, okay? It doesn't do that. We have hurricanes long before, so that's not the issue. Climate change does not cause tornadoes. It doesn't do that. What it does is it makes it more likely for extreme events to happen. That's what it does. Okay. So regardless of what you think the cause of climate change is, there are people out there who have this crazy theory proposed by that idiot Joe Bastardi, who says that a warmer atmosphere, think that the climate change, the warming of the ocean is caused by volcanoes. That's bullshit. But if you want to believe that, fine. It doesn't make a difference what you think the cause is. A warmer atmosphere means more water vapor, which means more rain can fall. What does more rain mean? More rain chances, heavier rainfall amounts, heavier rainfall events, and a direct increase in flooding events. Now, if you happen to think one of the people that you think climate change is a hoax, I don't know what to tell you. You're stupid. Sorry. Your politics are stopping you from understanding reality. It's just that simple. Remember, if your personal beliefs deny what's objectively true in the world, then they're actually personal delusions. They're not just beliefs. That's where we are right now, folks. Here's a sea surface temperature map, September 25, and we can see the La Nina developing very nicely here. Here's the negative AAM, and it's affecting South America. And then look at this amazing pool of extremely warm water here from China all the way through Japan, Korea, South Aleutian Islands. So this pool of warm water means that the oceans here on the Eastern Pacific were going to stay in a perpetually cold state. So we're going to have a negative PDO to deal with for most of the winter. But it's a little deceptive because it's not really cold here. It's just cold relative to this super pool of amazingly warm water. So that's why you get a negative PDO. I mean, you look at that warm water here off the coast of Canada into the Eastern Pacific. That doesn't look like a negative PDO, cold water in the Eastern Pacific. But compared to this, yeah, this is colder. So there you go. There's the Atlantic. It is beginning to cool down. We're beginning to see cold water push down from Spain and the Azores. Here's the sea surface temperatures as of September 18th to September 25. What's important to note here is that we had this large pool of really strong cold water on September 18th, around minus 3 degrees centigrade. See, about 100 meters down, about 160 longitude. It's gone. This is falling apart. And that's kind of unusual. Meanwhile, we still have a little bit of warm water off the coast of South America. So what this means is this is one of the reasons why the climate models are insisting this is going to be a weak La Nina. We barely get to a minus 1.0. If you look at the dashed black line, that's the ensemble mean of all these different reds and blue lines here. That's around minus 1.9, 1.0. It reaches a peak in December. Now look what happens in January. See this line here? This is the line January. It's already warming up in January. The La Nina is already breaking down, and it breaks down in February and March. By March, it's over. So this is a very short, shallow duration La Nina that's coming, that is in place. And it's going to be gone by the time we come out of Christmas or the beginning of the new year. So that's something to keep in mind for the winter. We're not looking at a big La Nina here. This is definitely going to be a weak event. Here's the latest stuff from the Hurricane Center. And there's mighty Hurricane Kirk, very powerful system, tropical depression 13. And this is the disturbed area here, so we can look at it a little bit. This here is the cluster of area here in the Gulf of Mexico, Yucatan, but looking at some concern for people in the Gulf, obviously. There's Kirk, looks like a monster hurricane, rapidly developed today. And there's tropical depression 13. You can see the satellite picture. I just want to show you what happened. You can see it really intensified with that eye forming. This is earlier today, you can see, and then it really took off. Boom. So, but it's head out to sea. There's no doubt about it. This is a fish storm, completely a fish storm. All right, let's take a look at some maps here and see what's going on. This is now for Friday, and you can see there's an upper low here, and this upper low is going to turn Kirk well out to sea. So this system is going to hit that upper low here and go like this. It's gone completely. You'll see that in just a minute. Okay, so then we have this a big upper low in central Canada, a trough of cold front coming through here. The front comes through, high pressure comes in for Friday afternoon. There's some sort of weather down in here, but it's very weak. It's very diffuse, not a big deal. There might be a couple showers in the East Coast with the front going through, but I don't think so. And then obviously we have this concern down here. Whoops. Then we get into Sunday, and now we have another very strong trough dropping in here. This one's much stronger, you can see. It's negatively tilted a little bit, and it's a much stronger cold front. You have a big Canadian high coming down. Look at those north winds bringing down the chilly air. Look at those lines, right? So that cold front's going to arrive here October 7th or 8th, sweep across the Midwest and the East Coast. Now we still have this area of disturbed weather here. By the way, there's Hurricane Kirk. You see what it's turning out to sea? Boom. See it, bye-bye. Fish storm. And then you can see this strong cold front racing across the Midwest on Sunday, headed to the East Coast on Monday. Sunday night, Monday. Now, I've seen this map a lot. People say, wow, they go, look at this. It looks like September. This doesn't look like October 17th. All these different lines, but these are all early systems. Okay, this is the next 4 days, and this is gone. So this is a little deceptive. After October 10th, you're not going to see this at all. So, I think people are hyping it a little bit too much. After October 10th, it shuts down. I'll show you why in a little bit. Now, this is the other system in the Gulf that people worried about. This is for Sunday. You can see the cluster of red line numbers here. This is showing obviously some sort of low pressure area tropical system trying to develop in the Gulf of Mexico. But as you can see, it doesn't come up into Georgia or Florida like Helene does. It stays very diffuse and gets blocked and goes into southern Florida, southwest Florida, then right across in the Bahamas. That's what all the data is showing. And there's a reason for that. We'll get to that in just a minute. One of the reasons for that is going to be, let me call up, to go beyond this. So this is now Tuesday, October 8th. So this big strong front comes roaring through, like we mentioned here, October 7th, and here it is October 8th, right? And the front just drives everything off the coast. We have this 1030 millibar high coming down, a nice strong autumn high, and any low pressure area that forms in the Gulf, look at this enormous trough. No chance of coming from the Gulf into the East Coast, not with this enormous trough here. No chance. Huge block in Greenland, gargantuan trough here, upper low in eastern Great Lakes or southwest Quebec, strong ridge in the Rockies. This is actually a pretty nice looking winter storm pattern if we were in the middle of winter. But anyway, that's why anything that forms here out to Florida, then gone, and the Bahamas, gone. I wouldn't worry about it, not at all. All right. Longer term, let's look at, there are 200 millibar velocity potential anomalies. Again, what we're doing here is we're measuring sinking air and rising air. This is sinking air. It's actually bringing high pressure to the surface. You have molecules of the atmosphere come plunging to the surface. That causes descending air, which suppresses clouds. Remember, clouds and rain caused by lifting. Think of a thunderstorm. The clouds get lifted up into the atmosphere, right? Here you have sinking air, which suppresses clouds. That's why high pressure, especially in the winter months, strong high pressure, you have blue skies and no clouds. Now, when you have a tropical disturbance or a low pressure area, hurricane, even nor'easter, what have you, you have low pressure lifting the moisture northward. And then you get your clouds and your rain. So on these next slides, let me show you what we can do. We can look at this the green represents rising motion. You're more likely to get rain and active storminess here. And the red represents sinking motion, suppression of the atmosphere. So for the next 7 days, right, here's the GFS ensemble, takes us to October 9th. Look at all the sinking air in the Western Hemisphere. Brazil, Central America, Central and Eastern U.S., the Western Atlantic. Now, there is some rising motion in the Eastern Atlantic, which is why we're getting all these storms in the Eastern Atlantic Ocean. Remember, right here, look at this activity here in the Eastern Atlantic, right? And then here we are for the next 7 days. Look at the green in the Eastern Atlantic off the coast of Africa. Bada boom, bada bing. Okay, that's the next 7 days. This is next year's week 2, and this is week 3. Look at the sinking air here. Now the Atlantic shuts down. Look, it stretches into the Eastern Atlantic Ocean here. Okay, and then you can see it shuts down completely. So we're in sinking air, sinking air. This is a fairly dry pattern for most of the U.S. And the Atlantic Ocean. It's a pretty dry pattern. A lot of sinking air here. I'm not getting a stormy pattern here at all. And we can see that because we saw this one for October 8th. Look at the morning temperatures on October 8th. Pretty chilly. Even towards the coast, you're going to be in the 40s. The coast. Get the upper 40s in Tennessee. Western North Carolina, obviously. And they're going to need the power back by then, so hopefully they get some power back. And you can see the mountains of New England and Pennsylvania, West Virginia Valley, maybe the Shenandoah, Western Maryland. They could see a frost in this area by October 8th. Not impossible at all. Very high probability of that event. Now, what happens afterwards? Well, that high drops southward, and again, any sort of tropical activity. Look at this enormous high, 1026, 1028 millibars, very strong for October, blocking any tropical activity. No chance, none, zero, don't worry about it. Okay, not happening. Here, my next slide here, let's talk about week 2. Well, there's our block. Let me blow this map up a little bit, you can see it. So this is the GFS, and bring it forward, here you go. Okay, so this here's our block in Greenland, the negative NAO, nice ridge in here, trough in the Eastern Pacific. So got a big upper low here and a trough right on the East Coast. The cold air is coming out of Canada straight down into the East Coast. Pretty impressive cold pattern, but only for the East Coast, not for the Midwest, the Ohio Valley. They're underneath this ridge. It's pretty warm, especially in the upper Midwest and the Plain States. Okay. That's the GFS. European showing the same thing. The trough is quite strong. It's a little closer to the coast. It's more on the East Coast than the GFS does, but there's the block, there's the strong ridge, very similar maps. There's the high pressure still dominating the weather for October 11th. Unbelievably nice conditions here. Not a drop of rain anywhere. Nice and cool. And then we go into week 2. Here we go, October 14th. Okay, we talked about this. Here's the trough. The ridge amplifies on the west coast, the Rockies into Canada. A new trough comes plunging southward, a very strong cold front here on October 14th, moves off the east coast, and then there's a reinforcing cold front behind that as the ridge moves to western Canada, which opens up the ice box here. So dropping the cold front right here through the east coast, okay? And there's another one coming in behind it. Look at these things. And that just dumps a whole bunch of cold air in. And then finally we get to 360 hours out. Look at this nice ridge in western Canada and the Rockies, deep trough on the east coast. I'm telling you, we have this pattern in December, January, February. It's going to be cold and it's going to be snowy for the eastern U.S. Now that doesn't mean we're going to keep this pattern. I'm just saying if we were to have this pattern. Very impressive. And finally, last couple of slides here, you can take a look at min temperatures on October 8th, and then look at this, min temperatures October 16th. Wow. Now that's the GFS. I'm sure it's overdone a little bit, but given the upper air pattern, it could be fairly close to reality. There's the middle of October looks kind of chilly. It really does. So now again, this is probably overdone for the Mid-Atlantic a little bit early, but not for the mountains, and certainly not for New England. And the Ohio Valley looks pretty chilly as well. So there's definitely changes around the way. This is meteorologist DT from Weather Risk. I'll see you over on the Weather Risk Grains Twitter page, and then over on the Facebook and on the website.